Hello, this is Mr. Gilmore with the 5.7 Applications of Hinge and its Converse. Let's use this time to take a look at the Hinge theorem and its converse in the use of application problems and in the application proofs. So we'll review what the Hinge and converse hinge actually say, and then we'll actually use them in some problems and some proofs to finish off Chapter 5. Let's review what the Hinge theorem says. It says that if two sides of one triangle are equal to two sides of another, and the included angle of one triangle is greater than the included angle of another, then the side opposite the greater included angle is the greater side. In other words, in this diagram here, if AB and DE are equal and BC and EF are equal, and the measuring angle B is greater than measuring angle E, then the side opposite of angle B is the greater, or the side opposite of angle B is the greater side. So in other words, AC is going to be greater than DF. The converse, then, we still have two sides of the first triangle equal to two sides of the second, but this time we're given that the third side of the first is greater than the third side of the second, then we can compare the angles opposite of those sides. In other words, since AC is greater than EDF, that means we can claim angle B is greater than angle E. Now we're going to use these in some application problems and in some application proofs. So we've done this example already, but when we review this example, that in a diagram such as this, we can actually compare angle 1 and angle 2. Now, how we compare them is based on what we are given. We first need to every single time determine that two sides of one triangle are equal to two sides of another. If that doesn't happen, then I cannot use hinge and conhinge. So let's check. I'm already given one pair of equal sides. As it turns out, these two triangles share a side, which means yes, I have two sides of one triangle equal to two sides of the other. The angle opposite then, angle 1 and angle 2 of my third sides, I can then compare them. Because I'm given that 2.36 is the side of AC and 2.37 is the side of BD, those are the third sides of my triangle, which means I can compare the angles opposite of those third sides. And since BD is the greater side, I know that the angle opposite of BD is the greater angle. And so if I'm comparing angle 1 to angle 2, I would have to say that measure angle 1 is less than the measure angle 2. And the reason why I would know that it's less than that is because of the converse of hinge. Converse of hinge helps us compare sides, okay? Converse of hinge helps us compare angles. So I can compare those angles based on the third sides using the converse of hinge. And so not only can I then compare those angles, but I can also justify why I know that those angles, when I compare them, angle 1 is in fact less than angle 2. Let's consider another example. Now, at first, when looking at this diagram, it seems a little bit confusing, but let me point out to you that we really have two overlapping triangles here. We have triangle ABC, okay, ABC, and we have triangle ABD. So those are the two triangles, ABC and ABD. What I want you to do is compare side BC to side BD. Now, in order to compare sides between two triangles, I have to make sure that I satisfy first that two sides of one triangle are equal to two sides of the other. Well, we're already given one pair of equal sides, AD and AC. And since these two triangles overlap, notice that they share a common side. AB is a common side, which means that does mean we have two sides of one triangle are equal to two sides of the other. Now, if I'm comparing sides, BC to BD, I need to know something about the angle measures. So if I'm comparing BD to BD, let's consider the angles opposite of them. The angle opposite of BC is this angle right here. I'll just call that angle 1. The angle opposite, though, of BD is this entire angle. We'll just call that entire angle angle 2, which are the angles BAD and BAC. Consider those two angles. Well, the entire angle BAD is the whole angle, and the angle BAC, or angle 1 in this case, is only a part of that whole angle, which means I know that I can compare angle BAD has to be greater than angle BAC. I know that because the whole is always greater than the part. So if I know that the whole angle BAD is greater than its part of the angle BAC, then I can compare the sides opposite, which the sides opposite are BC to BD. So the angle opposite of BC is angle 1. It's the smaller of the two angles, BAC. And the angle opposite BD is the bigger angle, angle 2, or side BD, the angle BAD, which means I can compare BC to BD. BC will have to be less than BD because the angle opposite of BC is the lesser angle. And this is actually using hinge. Okay, I can compare sides by using Hinge, and I use converse of Hinge to compare angles. Let's look at another example. Okay, this is actually a little bit of a tricky one, but it's kind of a fun one. What I wanted you to do is compare the sides BC to CD. Okay, BC to CD. And in order to do that, okay, in order to compare sides, we need a comparison of angles. Okay, well, in our given here in the diagram, we're only given the side measures BE and ED. Right? We're told that BE and ED are actually different measures. BE is 2.1 and ED is 2.2. So how are we going to get to a comparison then of angles to help us then compare another set of sides? Well, what we have here are we have two pairs of overlapping triangles that actually can lead us to our conclusion. Let me first point out our first pair of triangles, ABE, take a look at that triangle, and ADE. Take a look at that triangle there. We're given that those two triangles already have a pair of equal sides, and those two triangles share a side, AE. Do you see that? Which means two sides of one triangle equal two sides of the other, and we have a comparison of the third sides. That means we can compare the opposite angles, which are the angles that I'm actually having you consider in the given above, angles BAE and angles DAE. What can I then say about angle BAE? Well, the measure of angle BAE is actually going to have to be less than the measure of angle DAE, and here's why. It's opposite the lesser side. The side BE is the shorter side, 2.1. The side DE is longer side, 2.2, which means the measure of angle BAE is lesser or less than the measure of angle DAE. I can justify that, right? I can then compare angles. That's converse of Hinge. That I know that angle BAE is less than angle DAE. Okay, so now that we know that, how does that help us get to then the comparison of BC and CD? Well, we know that these two angles here, we're able to compare them. Well, consider that those two angles are actually part of a pair of other triangles. Consider these two triangles now, ABC and ADC. Looky that, okay? Oh, look, those two sides of those two triangles are equal, and they share a second side, AC. So are two sides of one triangle equal to two sides of the other? Yes, they are. So then I have a comparison of their angles. Remember, we were able to compare these two angles, BAE and DAE. That's what we just figured out with converse hinge. And since I have a comparison of the included angles, I can compare the sides opposite of those included angles. In other words, I can compare side BC to side CD. Well, since BAE is the lesser of the two angles, that means BC will be the lesser of the two sides. So BC is in fact going to be less than CD, and this is using our Hinge theorem. Hinge compares sides. And there we have it. In this one explanation, we had to use converse hinge and Hinge theorem to arrive to our conclusion about BC to CD. All right? So in some cases, you may actually have to use both converse hinge and Hinge to arrive to your conclusion. Now to finish off today's lesson, let's take a look at application of hinge and conhinge within a proof. Okay? So in this diagram, we're given that the length of AD is equal to the length of BC. We want to prove that side AB is greater than side CD. These are two separate sides of two different triangles, which means we're definitely going to have to use either hinge or conhinge to arrive at that conclusion. Now, since we're comparing sides, right, that's our conclusion, we're definitely going to need to use hinge. Hinge compares sides. Well, in order to compare those sides, we have to know something about the angles opposite of these two sides. In other words, we have to consider this angle right here, angle 1, and this angle here, angle 2. Those two angles are opposite of the two sides that we're considering, AB and CD. Well, I need to show that angle 1 then is greater than angle 2, because if I can show angle 1 is greater than angle 2, then I know the side opposite of angle 1, which is AB, is greater than the side opposite of angle 2, which is CD. So I can then conclude that AB is greater than CD. Well, let's jump into this, okay? Because there is something special going on about that angle 1 compared to angle 2. We can actually figure this out. So where we begin is with our given. We know that already we have one side of one triangle equal to one side of another. However, to use hinge or conhinge, we need to have two sides of one triangle equal to two sides of another. Well, good news is BD is a shared side. So I can call BD equal to itself by our reflexivity of equality. Now I have two sides of one triangle equal to two sides of another, but I need a comparison of those angles. Take a look, though, at angle 1. Do you know something special about it? If I consider this triangle BCD, I extend out the side, angle 1 is an exterior angle, and angle 2 is one of its remotes, which means I can claim the measure of angle 1 is in fact greater than the measure of angle 2 by the triangle exterior angle inequality, the TEAI. That means I have a comparison of angles. Okay, I have two sides of one triangle equal to two sides of another, and the included angle of one is greater than the included angle of another. I can then compare the sides opposite. I can say that AB is thus greater than CD. Okay, I'm comparing sides here, the Hinge theorem. So there we have it. I can then prove AB is greater than CD because I have everything satisfied in the given of Hinge, which means the side opposite of angle 1 must be the greater side. So there we have it, using Hinge and conhinge within some application problems and with application of proofs. Be sure to work or look at the 5.7 homework assignment. If you do have any questions on that, do not hesitate to email me and ask those. With that, be good and do good.